Multiplying decimals. I'll be honest, this isn't our favorite lesson, but we are going to show you what they want you to see before we actually try to give you a little better help on how to do it. We're going to start with the area models, just like we did with two fractions. So if you need two different colors, you can do it, or we can just shade them differently. But we can also use these to do the product of two decimals, just like we did with the fractions. Okay? I want you guys to analyze this model and then write the multiplication problem that is represented by it. So I'll let you try to do it by yourself. If you can't, talk to your table. I will give you a big hint. This is from 0 to 1, and there are 10 spaces going in each direction. Okay? See if you can figure that one out. We'll give you like 2. Okay, here's your key. When I look at it and I go across, I can see that this line goes up here. This line goes across to here, yes? So if I go across, that is 1, 2, 3, 4, 5, 6, 7 tenths. This one, I go up 1, 2, 3, 4, 5 tenths. And when I look at the double shaded, if I actually count those, how many are there? 35 out of how many total blocks? Do you see it? Good. The answer is 3,500. So 7 tenths times 5 tenths equals 3,500 hundredths. So from the area model, you should now be able to see this. So we've done an example for you. Now I want you guys to use the hundredths grids to write the expression 2 tenths times 10 tenths, 8 tenths, and determine the product. So we're going to model the expression and determine the product. So again, I'll give you guys about a minute and a half. You can either use two colors or you can just shade differently. Okay, so I am going to use two different colors because I want to make sure that this really kind of pops for you guys. So I'm doing 2 tenths. So we did 7 going up, so I'm going to do 2 tenths going up to try to keep it the same this class. I did it differently last class. So there's my 2 tenths, yes? Everybody agree with that? And then I'm going to multiply it by 8 tenths. So that means I'm going to go up. We'll do blue as the 8 tenths. And when we do this, especially with the nice colors, it kind of should help it make it pop what our answer is, yes? What is our answer? How many of those have two colors? 16. So 2 tenths times 8 tenths is 16 hundredths, because now I'm up to 100 squares.
I literally did the exact same thing, just like...
Okay? Now, Benny says the product of any two decimals that are less than 1 will always be less than 1. Angel says the product can be greater than 1. Who is correct? I actually want you to have a debate at your table. Figure out who's right. Is it Benny or is it Angel?
Benny.
Raise your hand if you think that Benny is correct.
What?
Interesting. Raise your hand if you guys think that Angel is correct. Guys, listen up. Here's a really big key, a big test-taking key. If I have someone that says always and another who says can be, most of the time, your can be is going to be correct. Because can be gives you a lot of flexibility. For it to be an always, it has to be absolute. Like there is no way it could happen. So if you're just using test-taking strategies, you would get this one wrong. Because in this case, Benny is actually correct. Now, the hint they gave you using the area model is actually really big. Because think about this. If I'm using my area model and both of my numbers are under 1, which is what he said, both of them are less than 1, is there any way I'm going to get a number in my grid that's bigger than 1? No.
It can be equivalent to 1, but not bigger.
Couldn't even be equivalent because the decimal is going to be less than 1. Could be an infinite number of 9s in my decimal places. It still doesn't reach 1, so I will never make it. So in this case, Benny is correct. You will never be able. Guys, way too much chatter going on. You'll never be able to have a number larger than the grid when they are both smaller than the grid. And what another big key piece of that is that word product. Someone said, well, if I add them, yeah, if you add them, you can get bigger, but we're not adding. It specifically says product. So anytime I multiply 2 decimals, I'm going to get a decimal answer is what that basically says. So if you multiply 2 decimals and you get an answer bigger than 1, you're wrong. Any questions on any of that? Does it help you visualize what's happening when we multiply 2 decimals? Okay. Good, because that's going to help us on this next section.
Yours too, it has vocabulary.
I don't think so. Oh, I did do this one too, though. Okay, guys. We're going to talk about a strategy. Kenji says, I use estimation to help place the decimal point correctly in the product, which can work. This is not the way I would do it. But again, estimation will help you understand if your answer is reasonable. So he says we've got the area of a floor is 32 7/75 feet by 7.5 feet. He estimates the products. 32.75 is close to 30. 7.5 is close to 7. When I multiply those, I get 210. So he knows the product is close to 210, but larger since he rounded down. So he multiplies the 2 numbers and he ignores the fact that decimals exist. Excuse me. Real quick, and you've got to be honest on this, because we're seeing a lot of struggles with multi-digit multiplication this year. How many of you are not comfortable with multi-digit multiplication? Raise your hand. Be honest, guys. Okay, so I see like 8 hands. Okay. So let's just talk about this real quick. So I'm going to go through this a little bit more slowly. Apologies to those of you that understand this. Just bear with us. When I'm doing multi-digit multiplication, I start in the ones place with my bottom number. Little Mr. Moore hint. Does it matter if I do 3,275 times 75 or 75 times 3,275? No, I'll get the same answer. Why? What property? Vivian? Thank you. Commutative property multiplication. It doesn't matter which order I multiply them. So to make it easier for you, I always do the one with less digits on the bottom, because you get to choose. So if I do less digits on the bottom, what that means is I'm going to have less rows to multiply. So all I'm going to do is I start at the 5, and I go 5 times 5 is 25. Put the 5 there. The 2 carries over to the tens place, because the 25, the 2 is in the next place over. 5 times 5 is 35. I add the 2. That gives me 37. I carry the 3. 5 times 2 is 10. Add the 3. I get 13. Carry the 1. 5 times 1 is 15. Plus 1 is 16. That's where I get the 16,375. I am now going to the tens place, the next place over. When I do that, I must put a 0 here. That's showing that I'm now in the tens place. If I were doing a hundreds place, I would put 2 zeros there. Okay? And now I'm just going to start at the 7. I'm going through the same process. So I've already used those numbers. I'll cross those out. 7 times 5 is 35. I carry the 3. 7 times 7, 49 plus 3 gives me 52. I carry the 5. 7 times 2 is 14. Plus 5 is 19. I carry a 1. 7 times 3 is 21. Plus 1 gives me a 22. So does everybody see where these two numbers came from and why they're there? One other key on this, you have to have neat handwriting. You must line all of your columns up and keep track of what goes where. So now I start adding. 5 and 0 is 5. 7 and 5 is 12. I carry the 1. 5 plus 1 is 6. 6 and 9 is 15, carry the 1. 1 and 1 is 2, plus 2 is 4. Nothing to carry, the 2 comes down. Now, by Kenji's, he said it's going to be close to 210. By having all those digits, he says, well, that means it should be around 245. So he just put the decimal here. Let us give you an easier way to do this. If I go back to my initial problem, all I do is count my decimal places. How many decimal places do I have here? 2. How many do I have here? 1. So total, that now gives me 3. I just write a 3 here and then I forget about it. So I'm kind of doing the same thing Kenji's doing. I literally multiply 3,275 by 75. When I get to my answer, now I go back and I say, okay, I need 3 decimal places. Where do we always start our decimal place in a number? Darren? On the right. So I start here. And I say, okay, I need 3 decimal places. So I just come in, 1, 2, 3, and that tells me where my decimal goes. This is what makes multiplying decimals easy, guys, because you really don't even worry about the decimal until you get to the answer. All you're doing is multiplying the numbers. But given what we've seen this year on your guys' multiplication skills, we are a little bit concerned on whether or not you're going to be able to do it. So please, if you're not good at it, practice. Okay, we want you to use Kenji's estimation strategy to insert a decimal point into each multiplication sentence to make the sentence true. So what do we mean by that? 52 times 6 is about 50. 8/10 is about 1. So that's going to be about 50. So where would my decimal go in this big number?
Up to the 5.
Nope. After the 3, because 43 is the closest I'll get to 50. If I put it after the 5, that's 4,365. Is that close to 50? No. If I put it after the 4, is 4 close to 50? No. If I put it after the 6, is 436 close to 50? You see how strategy works? Okay, so the strategy is valid. So try it with the next 2. Do this one by yourself. See how close you can get. I will say I was actually hearing a lot of really good conversations. Thank you for those of you who are stepping up and really helping your table understand it. So 7 and 9/10, that's about 8. 6/10 is about 1. Gives me 8, means I need 1 decimal place. 4 and 74/100. 94/100, that's about 1. 24, that's about 25. So it's going to be somewhere around 25, means my decimal needs to be here. So you see how the estimation can help you? Basically what they're saying, if I multiply the numbers, so if I do 526 times 83, it's going to equal 43,658. The estimation is just to help you understand where the decimal is going to go. Okay? Let's go to our next page.
All right, guys. 5. This whole table is you multiplying by whole numbers and decimals. I want you to do the first column, just the first column, and see if you can tell any patterns that you are seeing as you multiply these numbers. What is happening when you multiply these numbers? I'm going to give you about 2 minutes to finish just the first column, and then we will talk about it and finish the rest of the table. Go for it. All right, let's look at the first column. I am multiplying 32 by 100, so 32 by a whole number. Let's talk about this. Where's my decimal on 32? There's always a decimal, even if it's invisible. Where's my decimal on a whole number? On the right side of the 2, my decimal is here. If I am multiplying by a whole number, is my decimal going to move right or left? It is going to move to the right. So if I'm multiplying by 100, how many times is my decimal going to move to the right? Twice, and I get 32 with 2 zeros, or 3,200. Does that make sense? All right. Again, my decimal place is always after my 1s. And now I'm multiplying by 10, which is still a whole number. So is my decimal going to move to the right or to the left? How many times? 1. And I get 320. I am multiplying by 1, so it stays the same. Now I am multiplying by a decimal. So if my decimal is after the ones place, is it going to move to the right or to the left? Now it's moving to the left. How many times? 1, and I get 3 2/10. How many times is it going to move when I multiply by 100th? Twice. To the right or to the left? Left. And when I multiply by 1,000th, how many times is it going to move? 3 times. To the right or to the left? Left. And I get 32 thousandths. Any questions? All right, I want you to finish the table and do B. Describe any patterns that you notice as you go through this. 5. Now I am multiplying 3 2/10 times 100. So which way is my decimal going to be moving, right or left? How many times? Twice. All right, I'm multiplying 3 2/10 times 10. Is it moving right or left? Right. How many times? Multiplying by 1, it stays the same. Now multiplying by a decimal, is it going to move right or left? Left. How many times? 1. Next would be 2, and then 3. Any questions? All right. This one should be simple. Any questions? So what patterns did we notice?
The number will keep going down.
Okay, the number gets smaller as you multiply by a smaller number. What else?
They either get bigger or smaller by increments of 10.
Okay, what else? Fiji?
Like when you're multiplying, it's just going to like 100 and then like.
Okay, y'all are all just stating the obvious. Tell me about the decimals. Tell me about the things.
The more it moves to the left on the 32, the more zeros that the 32 is going to be behind.
Okay. How many places do we know many places to move our decimal? There we go. That's the question. How do we know how many places to move our decimal?
You move it like one place to the left every time it falls. Every time it's a 0. Yeah.
The number of zeros tell us how many times to move our decimal. Yes? Does that make sense? On a whole number, and are we moving it to the right or to the left on a whole number? Say that again. Right. All right, what tells us when it's a decimal how many places to move it? How many decimal places there are. So on a decimal, All right, so when you're multiplying by a whole number, the number of zeros tells us how many places to move the decimal to the right. And when we're multiplying by a decimal, the number of decimal places tells us how many places to move the decimal to the left. Does that make sense? Good, get it in your book. While you're writing that, I also want you to complete number 3. All of the answers are going to be 806, but you have to determine where to put the decimal in the answer based on the problem. Any questions? So you're doing 3A through H as well. You have about 2 minutes. Go for it. All right. 2 6/10 times 31. Are we multiplying by a whole number or a decimal? We have a decimal. So is my decimal and my answer going to move to the right or to the left? To the right. Nope. Try that again. To the left. Where is my decimal on a whole number? 806 doesn't have a decimal right now. Where is it? Nope. Nope. Where is my decimal right now on 806? It's not there. Where is it? Behind the ones place. So if I'm multiplying by a decimal with 1 place value, how many times am I moving it to the left? Once. So my answer is going to be 80 6/10. You can also say, because I have one number after a decimal in my problem, I have one number after my decimal in my answer. Does that make sense? Okay, again, I told you you could have 806 for each problem. This time I have 2 numbers after decimals in my problem. How many should I have after in my answer? Also 2. Does that make sense? This time I have how many decimal places? 3. So I should have 3 numbers after the decimal. This one I also have 3. So I should have 3 numbers after the decimal. Guys, I don't talk over people well. This one has 2 decimal places. So I should have 2 decimal places after the decimal in my answer. This one has how many? 4. So if I'm starting with 806, how am I going to get 4? Where's my decimal on 806 right now?
Behind the line.
Behind the ones, and I'm going to move it
In front of the 10.
4 places to the left. So what am I going to have to do? Add a 0, and I get 0 and 806. Make sense? All right, this one has how many? 5. So if I'm starting with 806, I know my decimal's after the ones place, and I'm moving it left 5 places, so I need to add 2 zeros. And the last one, I have how many decimal places? 4. So if I'm starting with 806 and I'm moving it 4 places to the left, I need to add 1 0. Any questions about that? All right, turn the page. We did it when we talked about it.
Yes.
Oh yeah, we did. You're right. Yeah.
Okay, so Selena's going with that pattern where she's finding, okay, we're multiplying by zeros, by powers of 10, I just add a 0, right? So she says, write a 0 at the end of a number to multiply by 10, and 2 zeros at the end to multiply by 100. Does everybody agree with that? Okay? So she says, 3 2/10 times 10 is 3.20 hundredths. 3 2/10 times 100 is 3 200 hundredths. Does that make sense? Why not? Did she just follow the pattern? She added a 0 after this number and 2 zeros after this number.
but it's not a decimal. So it needs to go up 2 zeros. So the decimal place.
Hold on, guys. Wyatt's giving some good answers here. Do what?
So the decimal place is going to go back 2 zeros. So if it's 32 times 10, it's going to be 32. Okay. 3.2 tenths times 10 is going to be 32, and 3.2 times 100 is going to be 32.
So what did she do wrong?
She added the zero.
Instead of,
decimal.
she should have moved the decimals. Okay? She needs to move the decimal, not add zeros. Now, the caveat on this is her method would only work with whole numbers. If I have a decimal, I can't do that. So her method only works with whole numbers. Does everybody understand why that is? Because it basically comes down to really what I'm doing is moving the decimal. With whole numbers, that means I'm moving my place value into bigger place values. So I add zeros to change the place value. Okay, explain the similarities and differences between these number sentences. So we have 32 times 10 is 320, 32 times 10 is 32. 32 times 100 is 3200, 32 times 100 is 320. So what similarities, what differences do you see there? I think, Richard.
That every time the decimals one cipher, right? Decimal.
So is that a similarity or different? So we'll go with Richard. So those of you guys that didn't hear him, what he said was the similarity is we move the decimal the same for each set. So when I have a 10 and a 10, I just moved my decimal over once. In that case, it made it 320. In that case, it made it 32. When I had 2 zeros, I moved it twice, made it 3200, moved it twice, gave me 320. Make sense? What's the difference? We just kind of talked about it in our reasoning up here, right? Vivian?
When you're multiplying whole numbers, move the decimal to the right, not the left. When you're multiplying decimals.
But we're specifically, both of these are being multiplied by the same, right? The difference is I'm using a whole number versus a decimal. So the difference is for whole numbers, I just add a 0. For decimals, I just move my decimal once. Make sense? So difference, whole numbers add a 0.
Write this on your paper, guys.
Decimals, you move the decimals. Yes, ma'am? Okay. Yes, unfortunately we have to give the test back because it was not good again. Yep.
Did we do better than last time?
Angry would not be appropriate this time. Disappointed would probably be better. Okay. Camilla says with multiplying decimals, the number of decimal places in the product is equal to the sum of the decimal places in the factors. Guys, this is the rules that we actually want you to know. Okay? And we're going to formalize this on the next page. But I'm going to go through this one quick. I multiplied 3 and 6/500 times 4 and 2200 on my calculator and got 15 and 403 thousandths. There should be 4 decimal places in the product, so it must actually be 1 and 5,403 ten-thousandths. Does that make sense? Is my rule right? That if I just count the number of decimals, I have 2 here, I have 2 here, means my answer should have 4. Is that correct?
Yes.
Somebody agree with that? You should, because that's true. This only has 3 decimal places. So here's where estimation can help you. If we estimated these numbers, 3 and 6/500 is about 4. 4 and 2200 is 4. 4 times 4 is 16. So does the calculator look like a good answer? Does her change make it look like a good answer? No. So, looking quickly at the numbers, 3 and 6/500 and 4 and 2200. Can someone tell me why there's only 3 digits in the answer?
Look at the hundreds places in both the numbers.
Uh-huh.
You can see that there's 5 and 2, which equals 10.
Good.
But you can't put 10 in the hundreds place, so you put a 0, which basically means nothing. So the calculator basically just removed it and just gave the answer like that.
I didn't have to even hit this time.
Awesome.
Good job.
Basically, there's a trailing 0 there. Calculator is going to drop a trailing 0. Because when I did the 2 times 5, my answer was 10 when I brought that down. That means the number had a 0 at the end. So really, there were 4 decimal places in the answer. The calculator just dropped the trailing 0. Does that make sense? So the calculator dropped the trailing 0. Any questions on that? So again, was our estimation difficult to do? Did I make it really easy to see which one was the correct answer?
Yes.
That's the advantage to estimating, guys. Okay, we're actually going to go forward 2 pages, page 141, because we've got a couple notes, a couple more vocabulary terms for you. Okay, guys. In mathematics, a kite is a special quadrilateral with 2 pairs of consecutive congruent sides.
Stop talking.
Another way to think of that, I have 2 different sized triangles that share a base.
Wouldn't a kite also be called a rhombus?
No. A rhombus is a specialized kite. You can call a rhombus a kite. You can't call a kite a rhombus. It's not a square because the sides are not equal. Yes. You can always go down in classification. You can't go up. We also have composite solids. A composite solid is basically a complex figure in 3D. It's made up of more than one solid geometric solid. So just like we did with complex figures, when we were trying to find the areas or volumes of complex figures or composite solids, you have a couple options. I could cut it and do this one and put it together. I could cut it this way and put those 2 together. Or I could make a hole and take away the missing part. So there's a lot of different ways to solve those, which you'll need to do on your homework. So that's why we wanted to make sure we covered that. Questions? Tell the bell. Uh-oh. Okay, so your homework, you're going to want to check the video because I'll give you extra hints because we need to hand out the tenths. Okay, so our homework is 2 pages, 143, 144. Describe a way to use estimation. We've talked about that as far as decimal plates. Basically, your estimation will show you how big the number should be.
Are
The only issue you come up with is when they are really close to going up to another level. Okay, this one is just like we did. We're inserting decimal points into each multiplication sentence to make it true. So the whole key is just basically count them, make sure you have the right number. Estimate each product to the nearest whole number, then calculate each product. There's two parts to this. You need to do your estimation because the directions say it, and then you need to calculate it. So we should see the work shown. Second page is pretty easy on this one. We didn't talk too much about this one, but to determine the volume of each figure, what you're going to need to do is treat these composite solids just like we did complex figures. Our volume formula is still length times width times height. On your diagrams, you're going to have two pieces. I've got this outer box, and then I've got this inner box that's being taken away from it. So if I calculate the volume of the outer solid, and then I take away the volume of the inner solid, that will give me my answer. On part B, you've got more options. This one, given the numbers we've got, is probably easiest. Just cut it maybe like this, and then you're going to just do the two pieces. Again, your volume formula is still the same, but you're going to have two pieces in each of these that you're going to need to do. On part A, you're going to take the second part out. On part B, you're going to find each volume, then add them together. And then the optional is a pretty good stretch one, but if you think about what's happening, you should be okay on that one. Good luck, guys.